Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing comprehensive questions on functions. So in this question, we are given three functions, f, g, and h. In A, we are required to find the value of k, given that h of 3x equals to k power x. So we're going to just plug 3x into h, and we get h of 3x equals 3 to the power of 3x. What I did here is to simply plug 3x instead of the x in the original function. Now, 3 power 3x is the same as 3 power 3 all power x, and this is equal to 27 all power x. So therefore, the value of k here is 27. In B, we are required to find the value of x when f of x equals g of 2. So first, let's find g of 2. G of 2 equals 2 to the power of 4, which is equal to 16. So f of x equals 16. And f of x is 7 plus 3x. So 7 plus 3x equals 16. We want to find the value of x. We take the 7 to the other side. So 3x equals 16 minus 7. 3x equals to 9. And then we divide by 3. So x equals to 9 divided by 3. And this is equal to 3. That would be the final answer for question B. Finally, for question C, we want to find f inverse of x. So f of x equals 7 plus 3x. And we can replace f of x with y. So y equals 7 plus 3x. We flip the variables. So x equals 7 plus 3y. We isolate the y. We take the 7 to the other side. X minus 7 equals to 3y. And then y equals x minus 7 over 3. And we can replace the y with f inverse of x. And this would be the final answer for C. So let's just circle our final answers to compare them to the marking scheme. So we have 27 in the first one, we have 3 in the second one, and we have x minus 7 over 3 in C. So we can move on to the next problem. In A, we are required to find f of 5. So f of 5 would equal 3 minus 2 times 5. This is equal to 3 minus 10, which is equal to negative 7. In B, we are required to find g of h of 3. So g of h of 3, we first need to get h of 3. H of 3 is equal to 4 power 3. And this is equal to 64. So we have here g of 64. And then we just plug 64 into g. So we get 4 over 64. And this is the same as, in simplest form, I mean, this is the same as 1 over 16. This would be the final answer here. And then in C, we are required to find f inverse of x. So let's just give ourselves some space. Here is question C, f inverse of x. So y equals 3 minus 2x, x equals 3 minus 2y. We want to isolate the y. Let's take the negative 2y to the other side to make it positive. So 2y plus x equals to 3. Now let's take the x to the other side. We have 2y equals 3 minus x. And we divide by 2. So y equals 3 minus x over 2. Finally, we replace y with f inverse of x. And this would be our final answer here. Now, in question D, we are required to show that HF of x equals 64 over 16x over 16 power x, excuse me. So let's also give ourselves some space and let's do question D over here. Now we want to get h of f of x. So this is the same as h of 3 minus 2x. We plug 3 minus 2x into h of x. So it becomes 4 power 3 minus 2x. We want to simplify this in order to obtain the expression that they want. So 4 power 3 minus 2x is the same as 4 power 3 times 4 power negative 2x. This is the same as 4 power 3 divided by 4 power 2x. This is the same as 64 divided by 4 power 2 all power x, which is 64 over 16 power x. And we have showed what they want for question D. And then finally, for E, we want to find the value of x when h of x equals g of 0.5. So let's first start by getting g of 0.5. So g of 0.5 equals 4 divided by 0.5. And this is equal to 8. So we want to get h of x equals to 8. Therefore, 4 power x equals to 8. We want to find the value of x. So the way to find the value of x here is to prime factorize 4 and 8. 4 divided by 2 gives us 2, divided by 2 gives us 1. So this is the same as 2 power 2 all power x. And 8 divided by 2 gives us 4, divided by 2 gives us 2, divided by 2 gives us 1. So this is equal to 2 to the power of 3. So 2 to the power of 2x equals 2 to the power of 3. Therefore, 2x equals to 3, and x equals 3 over 2. Now, if you check the answers, A is -7, B is 4 over 64 or 1 over 16, C is 3 minus x over 2, and D was a show that question. We already know that we got that right. And E is 1.5 or 3 over 2. So all our answers match the marking scheme. In this problem, we are given two functions, g of x and h of x. In I, we are required to find g of 5. So g of 5 equals 2 minus 5, and this is equal to -3. In double I, we're required to find h of 2. We start with the innermost function. So h of 2 equals 2 power 2, and this is equal to 4. We can remove this and we write 4. So now we have h of 4, and h of 4 equals 2 power 4, which is 16. So we can cross this out and write 16. So now we're left with h of 16, and this is 2 power 16, which is equal to 65,536. So this would be the final answer for double I. In triple I, we want to find x when g of x equals h of 3. So h of 3 equals 2 to the power of 3, which is equal to 8. So g of x is 2 minus x, so 2 minus x equals 8. We want to solve for x. We take the 2 to the other side. We get negative x equals 8 minus 2, which is 6. So therefore, x equals -6. And this would be our final answer. Finally, for IV, we want to find x when g inverse of x equals -1. So the quick way to do this is to understand that g inverse of x equals -1 means that the output is -1, and we want to find x, which is the input. And the smart way to do this is to just say that in g of x, the inputs and the outputs are reversed. So this problem is the same as in g of x trying to find the output when the input is -1. And in order to do that, all you have to do is just find g of -1, which is 2 minus -1, which is equal to 3. And this is the correct final answer. However, if you don't understand this concept or this technique, you can do it using the standard way, which is a little bit longer. So first you'll try to get g inverse of x. So g of x equals 2 minus x. Therefore, y equals 2 minus x. And we flip x and y. So x is 2 minus y. And then we want to isolate the y. So take the 2 to the other side. You get x minus 2 equals -y. You can multiply by -1 on both sides. So here we have -1, and here we have -1 as well. So positive y equals -x plus 2. Therefore, we can write g inverse of x as -x plus 2. And this is equal to -1. So we can take the 2 to the other side. So -x equals -1 minus 2. -x equals -3. And if we multiply by -1 on both sides, we get x equals 3 again. So in both cases, you're going to get 3 as the final answer. However, the way on the left, of course, seems to be much faster and nicer if you understand the concept of outputs and inputs. Let's check the marking scheme. So we have -3 for I, we have 65,536 for double I, we have -6 for triple I, and we have 3 for IV. In this question, in A, we are required to find h of f of 2 minus f of h of 1. So let's write them down more nicely. H of f of 2 minus f of h of 1. Let's start with the inside function. So f of 2 equals 2 times 2 plus 1. And this gives us 5. So we have here h of 5 minus f of h of 1. So let's get h of 1 here. H of 1 is 3 power 1, which is 3. So this would be f of 3. So now we have h of 5 minus f of 3. H of 5 is 3 power 5 minus f of 3, which is 2 times 3 plus 1. And I put it in brackets to simplify it first. So 2 times 3 is 6, 6 plus 1 is 7, and 3 power 5 gives us 243. So we have 243 minus 7, and this gives us 236 as a final answer. In B, we are required to find g of f of x, and we are required to give our answer in simplest form. Just for the sake of space, let's check one answer at a time. So for A, the answer is 236. This is correct. Now let's move on to B. In B, we are required to find g of f of x. So let's proceed. G of f of x is the same as g of 2x plus 1. So we need to plug in 2x plus 1 into g, into the x here. So we get 3 times 2x plus 1 minus 2. And this is 6x plus 3 minus 2, which is 6x plus 1 as a final answer. Let's check the marking scheme. We have 6x plus 1 in the marking scheme as well. In C, we are required to solve f of x greater than g of x. So for f of x, we have 2x plus 1. This is greater than 3x minus 2. We want to solve for x, so let's subtract 3x here. So we get 2x minus 3x, and let's take the 1 over there. So we have -2 minus 1. Now we have negative x greater than -3. We multiply by -1 on both sides. And remember, in inequalities, when you multiply by a negative number, you have to change the direction of the inequality. So it becomes x smaller than 3. And x smaller than 3 is the correct answer to C. In D, we are required to solve the equation h of x equals 1 over 9. So h of x is 3 power x, and this is equal to 1 over 9. In order to solve that, you need to write 9 as a power of 3. So 9, if we prime factorize it, if we divide it by 3, we get 3. If we divide by 3 again, we get 1. Therefore, 9 equals 3 power 2. And 1 over 9 would be 3 power -2. So therefore, instead of 1 over 9 here, we can write 3 power -2 equals 3 power x. Therefore, x equals -2 would be the final answer. And this is the correct answer for D. -2 is the correct answer here. In E, we are required to find G inverse of x. So G of x equals 3x minus 2, y equals 3x minus 2, x equals 3y minus 2. We take the 2 to the other side and get x plus 2 equals 3y. And then we divide by 3. So we get y equals x plus 2 over 3 as a final answer. Of course, we can replace y with G inverse of x after we're done. So x plus 2 over 3 is the correct final answer for E. In F, we have some algebra. We want to get 5 over f of x plus g of x. So 5 over f of x, which is 2x plus 1, plus g of x, which is 3x minus 2. We want a single fraction, so we have to have a common denominator. So you need to have 2x plus 1 in the denominator here, which means that you need to multiply the numerator by 2x plus 1 as well. Now we have a single fraction because we have the same denominator in both. So 2x plus 1 in the denominator and 5 plus this expression here. And we can start to simplify it automatically. 3x times 2x is 6x power 2. And then 3x times 1 gives us 3x again. Minus 2 times 2x is minus 4x. Minus 2 times 1 is minus 2. And then we can rewrite this expression as 6x squared. And then 3x minus 4x gives us negative x. And 5 minus 2 gives us -3. And this is divided by 2x plus 1. And this would be the final answer here. So 6x squared minus x minus 3. Excuse me, so this should have been plus 3 because this is 5 minus 2. We have 5 here and minus 2. So we just get plus 3, not minus 3. This is my mistake here. So we have 6x squared minus x plus 3 over 2x plus 1. This was the final answer. And then for G, we want to solve the equation f inverse of x equals to 4. So like I did in the previous problem, I said that there are two ways, the standard way and the quick way. Let's just solve using the quick way. So here, this is the output of f inverse. So it's the input of f. So basically, we can just write f of 4. And we can say 2 times 4 plus 1. And this gives us 9 as the final answer. And 9 is the correct final answer here. This is much faster and quicker than obtaining the inverse function and solving. Now for question 10, we are required first to find f of -1. So f of -1 is 1 minus 2 times -1, which is 1 plus 2, which is equal to 3. And 3 is the correct final answer to A. In B, we are required to solve 2f of x equals g of x. So 2 times 1 minus 2x equals x plus 4. Let's expand. We get 2 minus 4x equals x plus 4. Let's take the negative 4x to the other side to make it positive. And then that would be x plus 4x. And we can take the 4 to the other side. So this would be 2 minus 4, which is negative 2. So 5x equals negative 2. If we divide by 5, we get x equals negative 2 over 5 as a final answer. And negative 2 over 5 is the correct final answer for B. In C, we are required to find f of g of x. So f of g of x is the same as saying f of x plus 4, because g of x equals x plus 4. And we can just plug x plus 4 into f of x. And this gives us 1 minus 2 times x plus 4. We need to expand, so 1 and then negative 2 times x gives us negative 2x. Negative 2 times 4 gives us minus 8. So therefore, we have negative 2x minus 7 as the correct final answer here. And this is the correct answer to C. In D, we are required to find h of 2. So h of 2 is obtained as follows. H of 2, we first begin by finding h of 2. H of 2 is 2 power 2 plus 1, and this is equal to 5. So this is the same as h of 5, and h of 5 equals 5 power 2 plus 1, and this is equal to 26. So the final answer here is 26, and this is the correct answer for D. In E, we are required to find f inverse of x. So f of x equals 1 minus 2x, y equals 1 minus 2x, x equals 1 minus 2y. We take the y to the other side, as well as the x. So we get 2y equals 1 minus x. Y equals 1 minus x over 2. And then we cross out the y and we write f inverse of x equals 1 minus x over 2. And this is the correct answer for E. In F, we are required to find h of g of f of x. So h of g of f of x. We begin with g of f of x first. So g of f of x equals g of 1 minus 2x. And this is the same as 1 minus 2x plus 4. We plug 1 minus 2x instead of x in the function g. So instead of the x over there, we just put 1 minus 2x, and that's it. So 1 minus 2x plus 4 gives us 5 minus 2x. So now we want to find h of this expression, h of 5 minus 2x. And this is equal to 5 minus 2x all squared plus 1. So 25 minus 5 times 2 times 2, which is 20x, and then plus 4x squared plus 1. If you don't understand how I got this expression here, you can take this bracket and multiply it by itself. So 5 minus 2x times 5 minus 2x. 5 times 5 is 25. 5 times negative 2x is minus 10x. Negative 2x minus 5 is negative 10x, and this is positive 4x squared. So 25 minus 20x plus 4x squared is the expression here, which is what we obtained. Now we want to simplify, so 25 plus 1 is 26, minus 20x plus 4x squared. Let's rearrange this from high power to low power. So we have 4x squared minus 20x plus 26. And they told us that the answer is 4x squared plus px plus q. Therefore, the value of P is negative 20, and the value of Q is positive 26. And these are the correct answers as well. Here in A, we want to find G of half. So G of half is simply 2 times half minus 1, which is 1 minus 1, which is 0. So the answer to A is 0. In B, we are required to find f of h of negative 1. So let's start with h of negative 1 first. H of negative 1 equals 3 power negative 1, which is 1 over 3. So we want to get f of 1 over 3. And this is the same as 3 times 1 over 3 plus 4. 3 times 1 over 3 is 1. So 1 plus 4 equals to 5. And this is the correct answer. 5 is the correct answer to B. Next, we want to find G inverse of x. So for G of x, we have 2x minus 1. Y equals 2x minus 1. X equals 2y minus 1. We want to isolate the y. So x plus 1 equals to 2y. We divide by 2, we get x plus 1 over 2 equals y. And then we replace y with G inverse of x. So this is the final expression for C. X plus 1 over 2 is the correct answer. In D, we are required to find f of x in simplest form. So f of x is the same as f of 3x plus 4. And this is equivalent to 3 times 3x plus 4 plus 4. And then we can expand. We get 9x plus 12 plus 4, which is 9x plus 16. And this is the final answer to D, 9x plus 16. In E, we are required to find f of x all squared. So f of x all squared is the same as 3x plus 4 all squared. Of course, you can just multiply the bracket by itself. So 3x plus 4 times 3x plus 4. We can multiply the first two terms. 3x by 3x is 9x squared. 3x by 4 is 12x. 4 times 3x is 12x again. 4 times 4 is 16. So therefore, we have 9x squared plus 24x plus 16. And this is the final answer to E. And this is the correct answer. In F, we are told find x when h inverse of x equals g of 2. So let's first get g of 2. G of 2 equals to 2x minus 1. Now we have h inverse of x. Excuse me, I'm sorry. So g of x equals 2x minus 1. Here we plug 2 for x. 2 times 2 is 4, minus 1 gives us 3. So g of 2 is equal to 3. And h inverse of x is equal to 3. Like we said before, this is the output of h inverse. So it's the input of h. So we can just write h of 3. And h of 3 is simply 3 power 3, and this is 27. So this would be the final answer here. 27 is the correct answer. For our final question in this video, in A, we are required to find f of negative 3. So this would be 7 minus 2 times negative 3, which is 7 plus 6, which is 13. And 13 is the correct answer. In double I, we're required to find h of g of 30. So h of g of 30, we need to first find g of 30. And this is equal to 10 over 30. And 10 over 30 is the same as 1 over 3. So h of 1 over 3 gives us 27 to the power of 1 over 3, which is the cubic root of 27. So cubic root of 27 is 3, of course. How did I get that? You can either use your calculator or you can just prime factorize. So 27 divided by 3 is 9. Divide by 3 again, you get 3. Divide by 3, you get 1. So 27 is 3 power 3. And you can even plug it in here. So you get 3 power 3 all power 1 over 3, which gives you 3 power 1, which is 3. So the final answer is definitely 3. And this is the correct answer to double I. The answer is 3. In triple I, we're required to find f inverse of x. So f of x equals 7 minus 2x, y equals 7 minus 2x, and then x equals 7 minus 2y. We want to isolate the y. So x minus 7 equals negative 2y. So therefore, we divide by negative 2 on both sides. We get x minus 7 over negative 2 equals y. And we can remove the y and write f inverse of x. So this would be the correct final expression. Of course, x minus 7 over negative 2 is the same as 7 minus x over 2. They are both correct answers to this problem. In B, we are required to solve g of 2x plus 1 equals to 4. So this would be 10 over 2x plus 1 equals to 4. Since we have fractions, we can write over 1 and then cross multiply. And then 10 times 1 gives us 10. This is equal to 4 times 2x plus 1. We can distribute the 4. We get 8x plus 4 equals to 10. We can subtract the 4. So 10 minus 4 equals 8x. So 6 equals 8x. And then we divide by 8. So 6 over 8 equals x. Of course, 6 over 8, if you divide by 2, you get 3 over 4. This is the correct final answer here. 3 over 4, which is 0.75. And this is correct for B. In C, we are required to find 1 over f plus g. So 1 over 7 minus 2x plus g of x, which is 10 over x. And you want to have a single fraction. So you need to multiply by x here, and you need to multiply by 7 minus 2x here in order to get a common denominator, x times 7 minus 2x. But whatever we multiply by, we must do so in the numerator as well. So we have x here as well, and we have 7 minus 2x here. So now we have x plus 10 times 7 minus 2x, and we can expand. So we get x plus 70 minus 20x over x times 7 minus 2x. And this is equal to negative 19x plus 70 over x times 7 minus 2x. Negative 19x plus 70 over x times 7 minus 2x is the correct answer. Of course, 70 minus 19x is the same as negative 19x plus 70. So this is the correct answer here. Finally, we want to find h inverse of 19,683. So remember, this is a bit confusing because you don't know what this number represents. And here, if you cannot really get h inverse, you have to figure it out using the way of outputs and inputs. Here, this is an input. So it's an input for h inverse, which means it's an output for h. So therefore, we need to figure this out in terms of the output of h. So 27 power x equals 19,683. Now we want to solve this equation here. And even though it looks a bit scary, it's really not so scary because you can just figure it out conceptually. I apologize for these marks here. Now, we want to figure out what value of x satisfies this equation. So we can begin by prime factor, not really prime factorizing, but like dividing 19,683 by 27. And we figure out how many times we need to do that. So using your calculator, 19,683 divided by 27 gives us 729. And then we divide this again by 27. We get 27. And then we divide this again by 27. we get 1. So therefore, this is the same as 27 power 3. So therefore, x equals 3 is the final answer. And this is correct. This brings us to the end of our video. I hope this has been beneficial. Thank you for watching.